A quadratic equation in variable x is an equation of the form ax square plus bx plus c equal to 0 where a not equal to 0, a, b and c are real numbers. Consider the quadratic equation 2x square minus 3x plus 1 equal to 0. If we replace x by 1 on the LHS of this equation, we get 2 into 1 square minus 3 into 1 plus 1 equals 2 minus 3 plus 1 equals 0, which is equal to RHS of the equation. Then we can say that 1 is a root of the quadratic equation 2x square minus 3x plus 1 equal to 0. Also, we already know that 1 is a 0 of the quadratic polynomial 2x square minus 3x plus 1. In general, we can say that a real number alpha is called a root of quadratic equation ax square plus bx plus c equal to 0, a not equal to 0 if a into alpha square plus b into alpha plus c equal to 0. We can also say that x equal to alpha is a solution of the quadratic equation or that alpha satisfies the quadratic equation. Also, the zeros of the quadratic polynomial p of x equals ax square plus bx plus c will be same as the roots of the quadratic equation ax square plus bx plus c equal to 0. Now, let's see in detail about these roots or solutions of quadratic equations. We know that since the degree of a quadratic polynomial is 2, the solution will be at most 2 zeros. So in the same way, for a quadratic equation as its degree is 2, we can have at most 2 roots. Now, how can we find these solutions? Let's find out. For a quadratic polynomial, p of x equals ax square plus bx plus c, to get the zeros at the first, we need to factorize by splitting the middle term to get 2 factors in it. For example, p of x equals k into x minus alpha into x minus beta for some constant k. So the zeros of the quadratic polynomial are alpha and beta. So in a similar way, for a quadratic equation ax square plus bx plus c equal to 0, to get the zeros at first, we need to factorize by splitting the middle term to get 2 factors in it, that is k into x minus alpha into x minus beta equal to 0. Then either of the 2 factors can be equated to 0. So x minus alpha equal to 0 or x minus beta equal to 0, which means that x equal to alpha or x equal to beta. So the roots of the quadratic equation are alpha and beta. Now let's work this out in a couple of problems. Find the roots of the quadratic equation x square minus 3x minus 4 equal to 0 by factorization. For factorizing x square minus 3x minus 4 equal to 0, we need to split the middle term minus 3x into 2 terms in such a way that their product will be equal to the product of the x square and the constant term of the quadratic equation. So we can give the 2 split terms as minus 4x and x. Taking common factors from the first 2 terms and the last 2 terms separately and overall common factor from the resulting 2 terms, we get the 2 factors in the equation, and that is x minus 4 into x plus 1 equal to 0. So equating these 2 factors individually, we get x equal to 4 or x equal to minus 1. So the roots of the quadratic equation are 4 and minus 1. We can verify these roots by giving one of its values to x in the quadratic equation and check if it satisfies. Here we gave x equal to 4 and so that it satisfies. Now give x equal to minus 1, which is also satisfied. Hence 4 and minus 1 have been verified as the roots of the quadratic equation x square minus 3x minus 4 equal to 0. Now the next problem is 3 consecutive natural numbers are such that the square of the middle number exceeds the difference of the squares of the other two by 60. Find the numbers. Let the three consecutive natural numbers be x, x plus 1 and x plus 2. According to the question, the square of the middle number exceeds the difference of the squares of the other two by 60. So mathematically, we can write it as x plus 1 whole square minus x plus 2 whole square minus x square equal to 60. Expanding the square terms, we get x square plus 2x plus 1 minus x square plus 4x plus 4 minus x square equal to 60. Now simplifying this, we get x square minus 2x minus 63 equal to 0, which is a quadratic equation. Now let's factorize this equation by splitting the middle term. Then we get x minus 9 into x plus 7 equal to 0. So x equal to 9 or x equal to minus 7. But natural numbers cannot be negative. So x equal to 9. Therefore, the three consecutive numbers are 9, 10 and 11. So we can conclude that the zeros of the quadratic polynomial p of x equals ax square plus bx plus c will be as same as the roots of the quadratic equation ax square plus bx plus c equal to 0. And we can get these solutions by splitting the middle term of ax square plus bx plus c equal to 0 to get k into x minus alpha into x minus beta equal to 0 for some constant k. Then equating each of these factors to 0, we get the roots of the quadratic equation, which are alpha and beta.